We zijn vertrokken.
Okay, welcome for the session in the time hybrids, and this is it's a different one. It's not so based on the physics or mathematics, if you like, but it's biology. And the title is Evolution Creativity, and I'm going to just read it, not right on the blackboard, because it is a topic which doesn't require that. So evolution theory goes back to Darwin, let's say, and the concept was rather like random mutations and natural selections lead to a kind of tree of life where species branch off from the stem. And so that was a rather revolutionary idea in those times. The natural selection, of course, is a local thing and does not depend on the changes it forces in the genetic system of the species. It is independent of the reactions of the species. Well, 99.99%, I would say. For example, if you think of a human with 4 eyes, like I have now, that would be good. It would be a good mutation, because then if you have 2 eyes in your back, yeah, it would perhaps keep you alive with some predators which sneak behind you. So that is not a bad thing, and I guess natural selection would select it in the positive sense. But it didn't happen. Maybe there is a sort of cost in the system for the brain has to be used in a different way, the eyes are using more. Anyway, there is a certain kind of cost-benefit analysis, I guess, and it didn't happen. So, but what did happen was the perfectioning of the eye functioning, and all the mutations that we see go in the direction of growing complexity. If there is a bad one, yeah, maybe it leads to extinction in an extreme case, or you become underdeveloped in another case. But really, after a while, and maybe it's a long while in evolution theory, all these things develop in the direction of more complexity, and not only the humans, but all organisms seem to evolve in a way of higher, better complexity and a better functioning of the system. So, is this created by the selection or by the biotope? I don't think so. It is created by the reaction of the organism to the selection. So this is a rather important other point of view, I would say. Most people in biology would say the natural selection does this, the natural selection does that, but the natural selection doesn't do anything. It's the organism doing everything. And if the system changes, okay, the organisms react to it. And so I would say that the growing to complexity is not done by natural selection, but by the reaction to what the selection does. So the reaction of the organisms. The internal functioning usually goes in the direction of economical use of material. You don't want to spend too much energy on something futile. For example, the mutation of cells is not in the mutation of species. The cells have their own genetic changes, which in fact define in the end the genetic structure of the species. They all come from cells. For example, cancer is developing in the cells and not in the genetic structure of the species. There is, of course, perhaps some kind of possibility to develop cancer, but and the epigenetic structure could then interact with this or not, I don't know. It could perhaps prevent it or not. But so this belongs to the cells and not to the species. What we see in the evolution of all animals, I think it is clear that the mutations are not very drastic. It's not so that the giraffe has 2 necks or 5 legs. The mutations are always rather infinitesimal on a small scale, and usually almost invisible even, I would say. The changes are slow also, they go over a longer period. Um, so it is rather amazing that the different species are still close in genetic structure, if you assume that the genetic changes would be random or not really very controlled. And it would be a more divided spectrum, I think. This is hard to prove, but it is, in my opinion, remarkable that our genes, our genetic, our genome corresponds for very large numbers, a very large percentage with the, I think it's like 70% with the donkey, and of course with some apes over 90 something. So the genetic structure is sort of infinitesimal, close almost, let's say. Okay, so the changes in the structure of animals and things in the biotope do not change the natural selection. Natural selection goes on as before, but the species react differently. And what it does is that they create, and this is due to the species and not to the natural selection, they create new possibilities. So they are opportunistic in a sense, and they use the changes in an opportunistic way, not just to survive, but to become better and more complex. So trying out new possibilities created by the earlier history. So the natural selection and mutations, they respect in some way the history of the evolution at that moment. So the effect of the history is sort of conservative in the changes. That is perhaps the reason why the changes are not so drastic. The changes in the genetic system are, and this is discovered by mathematicians, by the way, they discovered that DNA is a knot with, I don't know, 300,000 crossings or something. And the mathematicians have an invariant from knots, it's called the Jones polynomial, which gives you the complexity of the knot. So they calculated the Jones polynomial during the change, the splitting of the DNA, and they discovered that the values of the Jones polynomial change. So that proves that in this process the DNA is cut and glued. It's not just a knot that you undo, it is to go fast, because they were surprised that this happens rather fast. And so they discovered that it goes fast because the something was not know what at that moment. Something cuts and glues the strings. And later they found the enzyme that did it, and they called it a topoisomerase. Topoiso for the topologist. Through the topologist they discovered this variance in the Jones knot. Okay, so this cutting and gluing creates errors, but the errors are small, sort of in one or two places. It's not that they change the whole genetic system. So the use infinitesimal is a bit wrong, I guess, but small changes, not too drastic. So the mutations, I also met them in the model, the DIM model. Mutations are when the manifestation is not really consecutive, it stops at a moment, and later in the same long string, maybe some creative potential is there, or some coherence, which I will talk about later, is high enough so that it begins to exist, and then the existing thing is not identifiable to the original object where it comes. It only has the long string as the common basis. And of course, being in the same long string is a stringent condition. It's not just a very little fact to be in the same string. It is important. But it doesn't mean that you're identical to the other realizations. So the mutations are different from the manifestations, but the difference is controlled. It's not arbitrary. It's controlled because it's in the same long string of the process. Therefore, the fact that I say stringent condition, pun intended with the word string, is to say that it is not so arbitrary. It stays on a big level, or a high level, close to the manifestations, but it's not identical. So this creates a flexibility. And so I was wondering, I cannot prove it, but I was wondering whether the existence of mutations, so the fact that the process stops with the manifestations and goes to the mutation sometimes, it's even possible that every manifestation is in fact a mutation, but completely very, very, very tiny, not even genetical, but in the potential level of the real changes, not in the existing changes. I think that it's possible. I think it's almost certain. Something changes, and that is enough to be a mutation in a sense. Of course, in a moment, and in the next moment, or well, close to that, there will not be very drastic changes, but there are changes. So I incline to think that, in fact, we don't have to talk about manifestations, but everything could be mutations. And some are over longer intervals, or some are more serious than others. But okay, fine, I don't care. Maybe they're manifestations and mutations. But this system of changes, which is perhaps the general word, the changes of the structure of the thing, is to have flexibility. Because the organisms have a kind of, I'm not saying that they know something, but they have behavior with respect to the biotope they live in. They try to adapt. That's a fact, I think. So when they adapt, they make a choice. They do something, they may be creating an original pre-thing in their process, which is our idea of creating a new idea or something, but much more advanced, of course. But maybe the primitive cells even could create some new interaction in a certain moment. And then that is, first of all, a version of free will, and secondly, they create their own interaction, the creative potential. And I talked about the learning process in the other lecture. There is creative things when you do a process over an observation or a study, a learning process or whatever. So that is inside the dim model, very plausible that this flexibility comes from that. And then I don't say this is a planned flexibility, but it's a flexibility with a reason, I would say, or at least an origin. Okay, so this flexibility allows certain new developments. Okay, so instead of the Darwinistic view, I would say perhaps we should view evolution as an open opportunistic system which enables possibilities, which growth at each step, and maybe not every step separately, but on the whole, in the positive direction of complexity. And the fact is that everything has evolved into growing complexity, that's a fact. So it's reasonable to say that this was what happened. So the danger of mutations destroying everything seems to be very, very small. And this happened over many species, even not genetically close even. There's some kind of parallel developments, different but sort of parallel. So I would say that mutations have an interspecies field of definition. Many species have two eyes. Not only fish, and we come from fish, but also insects. There are insects with many eyes and very different. But there is a kind of strange phenomenon that 4 legs, 6 legs, there are certain forms which are abundant in the evolution. And 2 eyes is one of them. 1 heart, not many with two hearts. So this seems to be a kind of economic principle on some levels, but on other levels, a kind of safety that two ears, two eyes, if you lose one, you still see and hear. This is important. Okay, so is there a control of organic life? Organic life, you see, life is sort of the set of all living things, but it's also the relations with the living things amongst themselves, interspecies, like symbiosis, but also with the biotope. And so organic life includes all the relations of living things with whatever. Other living things, dead things, the biotope. And I guess humans have in the recent period stretched their influence on the biotope too far. And we are on it's not exaggerated to say at the threshold of extinction. We have already created a large extinction between organisms in the recent century, let's say. Okay, so the organic causality depends on all interactions, as I said. So evolution also is a process, and the interactions with the biotope are in it. And causality of things can be in mutations, yes, but the organic causality depends on all interactions, even in the universe. I not say that there is a big influence of some interaction from Orion on the heat in Antwerp or something, on the biotope. Maybe not, but you never know which interactions, even very far away, because these pre-interactions, where the interactions come from, they are in the void, and in the void there is no distance. In the void there is time, but time is only the ordering, as I said, and as we used. I didn't use any numbers or parameter or variation. Duration of time is not there. There is only the total ordering. And the total ordering is in the void. And the processes are ordered. So there is a lot of structure there. And evolution starts from the void and is related in the void with interactions which could be very far away later when they exist. So they can be, I can define a proximity in the void if I use my assumption on the non-commutative topology on the states, because then you can look at filters of smaller and smaller sets containing something, and the smallest one, or the limit if you like, gives you an idea of proximity. So the one's somewhat in a bigger one and others are in a smaller one. Small is contained in it, not by any number. So there is a possibility to define some proximity, and this could play a role in interactions. Things that are more proximate than others, they could interact more or with a higher intensity. There is intensity possible. I didn't study that. But anyway, this in the void, the fact that there is no distance also explains, which I will do in some other lecture, entanglement in quantum theory. Entanglement is starting in the void, and it's not spooky at all to have later existing interaction very far away. A process of interactions can grow to an interaction in a place which is far away or close, because in the void there is no place, there is no distance, I mean. The distance in the realization can be very large or small. So entanglement seems to be okay over very large. It's not depending on the, stays independent of the distance, like in the void. While gravity, from the gravity in the void, there is a kind of gravity there. I developed a field theory, cohesion. And gravity, when it realizes, it is depending on the distance. Entanglement is not depending. So there's not spook at all, it's just one or the other. Okay, so after all that, I must decide that also in this perhaps new interpretation of evolution theory, that the evolution process is related to all aspects of being in evolution, and this relates to the whole universe, to all interactions in the void, from the whole universe there can be an influence, a dark effect, or other influences. I also define them in another section. They have some respect of history, so some kind of conservatism, but they change regularly, and this is progressive, but with some respect to conservatism, and perhaps this would be a solution for the United States, I think, but it's a side. Evolution in the learning process of the ingredients of life process, instead of looking at species, we can look at the process life. Life is, in my definition, a pseudo-organism, which means it's a group of living things together, which depend on each other, and like a beehive, let's say, I call that a pseudo-organism, or society is a pseudo-organism. It has several aspects, not that it eats or something, there's no metabolic system, but it has a lot of aspects of an organism, the organization of energy and so on. So I call that pseudo-organism. So life is a pseudo-organism, and the evolution is really the learning process for the ingredients of the life process. The evolution varies, and it is in fact, in my opinion, what if life doesn't have a brain, but it has a learning process, which is evolution, and that is a deformation. The aspect deformation of it is a micro process, and these have creative interactions or links going back, as I said, in the learning process. The anti-causal or anti-logical links, they are creative. So these are going in the direction contrary to the ingredient links, or contrary to the life evolution. So it means, when I apply this learning strategy, the theory I developed about the learning process and the micro process, the understanding process, if I apply this to the pseudo-organism life, I conclude that life applies creativity in the process, in the evolution process. Of course, this is not so surprising for many people, because you think it's about creation anyway. But it's strange that when people say that, they usually think of God or something. Fine, it's possible, but it's also possible that it's just the organization of life as a process and as a learning process with anti-causal links, creative links, and then you have to say that it creates. So life itself creates certain phenomena in the evolution. That people say, okay, it's nature. In a sense, I agree with that. Life can be called nature if you like. But as a process, it is defined like all other processes, and it has anti-causal links. And so that's where evolution is creative, and the title of the section today was Evolution Creativity. So as a conclusion, I would say that, okay, mutations are not really random. Random, in fact, doesn't exist in my model. Everything has intrinsic reason. So mutations are even organic, causal. In reality, they come from momentary potentials. And all links in the evolution play a role. So the creative anti-causal links create this evolution creativity, and as a conclusion, you can say it applies to most of events which fit in the usual consecutive manifestations of the process, so in the evolution. So what kind of things are creative then in this process, which do not fit in the natural process you expect from the ingredients? Well, the only thing that I can think of immediately is mutations. Mutations are the real places where something anti-causal can happen. Mutations are unexpected, unpredicted. So even from that point of view, you have to agree that they are creative, they are new. But so they are creative and new, but fitting in a process where that is natural. And that is then a conclusion which gives another point of view on the evolution theory, which is then an opportunistic system enabling new possibilities. not just a tree of life, it's splitting. I don't think it comes from one cell. It comes from billions of cells. Different craters, different black smokers on the ocean bottom, different chemical compositions of the organic, the blobs of chemical stuff that floating around with a membrane and a skin in the end, and a cell. The contents was different. So there were many cells, and the evolution is not starting in one point. This is a human mistake to think that everything comes from one. The Bible story about Adam is an example, God is perhaps an example. Well, the origin of life is also an example. I mean, there are many, many millions or billions of cells with different structures evolving. Okay, so as I said, I use organic causality in this interpretation, and it is different from observed causality, and it can be even observed random, as I said in the causal lecture. So that makes it maybe in one sense chaotic, that non-causal observation like observed random are in fact organically causal, but that is just the deeper structure of reality, I guess. And so it is proving the core structure of observing. So the difference is not in the thing, the difference is in the observing. And for this, not the first time, we have to conclude that observing is a very crude approximation. And also in evolution, we have only very, very few observations, and over very short time periods. With the fossils, they can do a little bit better, but then you use carbon dating and things like that. So there is a lot of small, I would not say incorrect or something, but small deviations in possibilities that are observed to what is existing and certainly to what is non-existing in the void. Okay, so if you take care of all the interactions in the universe, we get a completely new interpretation of things. And this is on the level of interpretation, but I think with some more research one can actually get some deeper results. This is a hope, I say. So that's the end of this section, and I think we're just in time.
Perfect. Thank you very much, Fred, for this inspiring talks and series of talks.